Okay, so then you can see to calculate the value of C, that will give you that phase shift. You just calculate C is 10 to the power of 6 divided by 2 pi 50 times XC. So all of these problems, we always want to know what is the value that would give us a 90-degree or an 80-degree phase shift so that the motor can start. Okay, again, if we look at the exercise, question 1 says, we have a 50 Hertz single phase capacitor start. Come on, focus. Induction motor has a winding impedance of the main winding is 4.3 plus J3.5. Auxiliary winding is 9.6 plus J3.2. Calculate the capacitance of a capacitor to be connected in series with the auxiliary winding to give 90-degree phase shift between the currents of the two windings. So again, that is the condition that we have. Main winding is 39.14 and the auxiliary is 18.44. So therefore alpha is 90 minus 39.4, which gives us a value of 50.86. So now we've got 18.4 and 50.86. So this one, first of all, we break that up into the rectangular form, 9.6 and 3.2. All right, that was given. So now we can calculate that value, which is the 9.6 times the tangent of 50.86. Then we get 11.796. That's a bit off. Can you see it? Right, and then 11.796 plus 3.2 gives me 14.996. And then if we calculate frequency, capacitance is 1 over 2 pi fxc. So basically all these problems are going to be like that. You think you'll be able to do them? All right, don't just all say yes at once. I'll give you some time. Oh, you're getting cold or what? Huh? With that hoodie and that Moorse jas. Must be very cold there where you sitting. Is Mr. Manyaba. Okay. Are you guys okay with that? Shall I do another one? They say the standstill impedance of the stator winding of a capacitor start where the frequency is 50 Hertz. Sorry, 60. That of the main winding is 1.4 plus J4, and the auxiliary is 3 plus J6. So they want a capacitor that would make the phase angle between the two windings 80 degrees, not 90 anymore, so basically the same. So this one, Z main, is going to be 4.28 at an angle of 70.71. And the auxiliary winding is 6,708 at an angle of 63.4. Right, so there we have it. Voltage, main 63.4, sorry, that's the auxiliary, and the main is 70. Now they want us to calculate the value for alpha, not 90 anymore, but later 80. So that is then alpha is then 90 minus 70.71 and 80 as well. That gives us 9.29 degrees now. Okay. So if we look at now, there we have the main winding, and the auxiliary is 3 plus 6. And now we have to find that value there, the angle of 9.3 degrees or whatever, 0.29. So let's call that A, O, and B. So AO is going to be 9.29 out of 10. Tangent of 9.29 times 3. That should be 0.491. And we know that OB is 6. Therefore, XC, which is this, XC is going to be 6.491. And C is 1 over 2 pi times 60 times 6.491. Again, it must be 10 to the power of 6. Yeah, what the hell is going on here? That gives me 408.58 microfarad. Okay. Sorry, guys. Okay. Then the third one, it says Z main is 3 plus J4, and that is equal to 5 at an angle of 53.13. And the auxiliary winding is 5 plus J3.44. That gives you 6.07 at an angle of 34.5. Now, again, we have a problem here where we have O there, and 53 for the main. And 34.5. Right, now they say they add a 300 microfarad capacitor. We must calculate the additional resistance needed in the starting circuit to give optimal starting torque. So we know that alpha is going to be 90 minus 53.13 gives us 36.87. And if we draw this now nicely, the 34.51 is 3.44 and 5. Here's a little bit of resistance short in this circuit here. 36.87 degrees. So XC is then 1 over 2 pi, it's a 50 hertz. And let's say it's 50 hertz, 2 pi 50 times 300 times 10 to the minus 6. That should give us 8.84, I think. Let's check quickly. Whoa, whoa.
Ten, comma, 6.
You get 10.608. So XC is then 10.609.
6.1.
Hmm?
Yeah, that's correct.
So therefore, minus 3.44, that is 7.2. Okay. Now, what is this value? Cos of 36.86 is adjacent. No. I'm going to look at 10. 10 of 36.87 is 0.2 over, let's say, x. So x is 36.87. Then divide 1.56. And if we subtract 5 from that, our external is 4.56 ohms. Phew. So let me just admit this guys again.
Oh, the resistor is here. Oh.
Let me see something here.
Okay. Mm-hmm.
Okay. All right, that concludes this part of the work. Then we're gonna skip up until page 208 in this handbook. What I'll do, you go through those work in the meantime, and then I'm going to resend you the stuff that you should learn. So go through. I don't know what happened, but I sent you the wrong ones. Let me just check quickly again.
Is it there?
Okay, any more questions that you have? I don't know if you're gonna get this handbook in the meantime, but I'll send you, I don't know. How many of you don't have this book? You should have them more because you've done motors of DC machines and AC machines.
No, sir, we don't have that one, sir. We've got the other one, the one you were using for what's this? The one you're using for the what was it? Is it the one you're using for induction motors, sir?
Yeah, machines too.
Yes, sir, we have that one, sir. Not this one.
Ish. Raja, something is the special things in. Okay. Okay, single phase motors, yeah. AC series motors. Okay, what I'm gonna do, I'll send you these chapters as well. And then if you go through the notes or the video that I've made on the universal motor and the alternator, I'll send you this stuff. And then we've covered basically everything. But I'll see what I can do, and then I'll find out what is in the test, and I'll let you guys know. So, is it still on for next Monday, or do you want to do something during the week as well? I've only got
Next
Wednesday
Monday
as well, sir.
Pardon? I've only got Friday night open and Saturday.
Yo, not weekend. Next week Monday will be
So what about
Yeah.
Friday, sir?
Ow.
Hey, you can't drink, so and you can't smoke, so forget about it. So what's a party without booze and and cigarettes? Right, I'll be here Friday at 8.
Yes,
If
sir.
anyone wants
Yes, sir.
to ask questions, I'll be here and then I'll record it as well.
Okay, sir.
Right, guys. Have